and first I will start the recording,
Recording in progress.
share the contents. Okay, so in the last lecture, we have started a special case of mesh and node analysis, that is super mesh and super node. So here we have discussed about super node method, and we have taken this example. So do you have any doubt in this? If you have doubt, then I will start again. I will again explain the super node method. If you have any doubt, you can ask. Yeah, we have started from here, the super node analysis.
Sir, could you please explain it briefly again?
Okay. So again, I am taking this same problem and okay, so this problem we have taken for super node analysis. So in this problem, if you will see clearly, there are two nodes and one is reference node. Because we have provided ground here, so this is reference node. Remaining two nodes are there in the circuit, and the voltage at two nodes are given here, V1, V2. If it is not given, then we have to denote the voltages at these two nodes. Suppose this is node 1, node 2. Okay, so I told yesterday that the super node method is applicable, or it is helpful in the circuit where, if you will see, in between two nodes there is a voltage source connected. Okay, so if in between two nodes, you can see that between 1 and 2 node there is a voltage source connected here. So as per the super node, we will take this combined unit as a single node, as a super node, and we will apply KCL. As you know that in nodal analysis, we will apply KCL at the nodes, and we will try to find out the different equations, KCL equations, based on the number of nodes. Okay, so if you'll apply KCL, this will be super node as per the principle. So by applying KCL at super node, and before that we have to assume the current flowing. Okay, so suppose we have assumed that the current flowing is downward. This is I1, this is I2, this is I3. We can take any direction of current. Okay, there is no issue. If your assumption will be correct, you will get positive sign after solving. Okay, the current value will be positive. If it is coming negative, means you have to reverse the direction of current that you have assumed previously. That is very simple. You can take any direction, whatever you want. Okay, there is no issue. So by applying KCL at super node, this whole node will be considered as a super node. So you can see that, as we have seen in the previous lecture also, that this element, you can see that the terminal of this element, as per the super node, the voltage will be same. So that's why we will not consider this as an incoming and outgoing current. So what are the currents, incoming and outgoing currents to this super node? This 2 ampere is there. then I1 is there, current through this 2 ohm, current through this 4 ohm I3, and the 7 ampere. Okay. So as per the KCL, we know that the incoming current is equal to outgoing current, or algebraic sum of the currents at the node will be 0. Entering and leaving to the node is 0. So the incoming current at the passive current convention, we will take incoming current as a positive current, outgoing current as a negative current, or you can simply write incoming current one side, outgoing current another side to the equal sign. So incoming currents to the node is only 2 ampere, outgoing current I1, I3 and 7. So 2 is equal to I1 plus I3 plus 7. So it means I1 plus I3 is equal to minus 5. What is I1? Now in this case, what is I1? You know that at reference voltage will be 0. Okay, because you have provided ground. So when you have assumed the current direction downward, what will be the value of I1 in terms of V1?
V1 minus 0 by 2.
Right. V1 minus 0 by 2. What is the value of I3?
V2 minus 0 by 4.
Right. V2 minus 0 by 4. Simple. Very simple. So now we will put the value of V1 and V2 at previous equation. Suppose this is equation number 1. And if we are putting the value of I1, I3, so this will be V1 by 2. This will be V2 by 4. V2 by 4 is equal to minus 5. This is equation number 2. Okay. So we have one equation where V1 and V2 two are variables. Okay. And this equation we obtained by applying KCL at supernode. Okay. I told you in the previous class also, whether we are applying supernode or supermesh analysis, we have to apply both KVL and KCL. Okay. So we have applied another one KCL. Now we have to take KVL equation so that we can get another equation in terms of V1 and V2. So how we can get KVL equation in terms of V1 and V2? If we clearly see our supernode, so in supernode V1, V2 and 2 volt is there. So there is a relationship between V1 and V2. If we apply KVL from here to here or from here to here, we can clearly get another equation, that is KVL equation. So by applying KVL, at supernode. So if we assume that V1 is greater than V2, okay, if we assume that V1 is greater than V2, it means clearly we denote that this current is I4, means current will flow in the sources, current will in the elements, current will flow from lower potential to higher potential. Higher potential to lower potential. In the elements, current will flow from higher potential to lower potential. So if we assume that V1 is greater than V2, so by applying KVL, we can write V1 plus 2, that is 2 volt due to this voltage source, minus V2 is equal to 0. It means we have got another equation, that is V1 minus V2 is equal to minus 2, equation number 3, right? So if we solve equation number 2 and 3, we can easily get the value of V1 and V2, right? So V1 we have identified V2 we have identified. Now we can easily calculate the value of currents. Okay, I1 we can calculate, that is V1 by 2. I3 we can calculate, that is V2 by 4. I2 we can calculate, that is V1 minus V2 by 10. Okay, I2 will be equal to V1 minus V2 by 10. Simple. And I4, value of I4 we can easily calculate by applying KCL at node 1. Okay, so by applying KCL at node 1, there is one incoming current and 3 outgoing currents. So I4 will be equal to 2 minus I1 minus I2. यही मिलेगा.
Yes, sir.
So I think now it will be clear to you that how we can apply super node.
Yes, sir.
Okay, first we have to see in the circuit, whatever circuit we got, first we have to see that is there any case where in between two nodes there is a voltage source connected. Voltage source can be independent or dependent. Whatever the voltage source is there, if it is voltage source, we can apply super node easily and we can solve our equation, okay, in a simpler way. If we go for any other method, it will take time, definitely, because we have to get more than two equations to solve this problem. If we look at this problem only, we have to solve, if we go for another method, another alternative to solve this circuit, so for that we have to solve many equations. There will be many equations, more than two equations. But if you look at the super node method, in this problem, by using only two equations, we can easily get the values of voltage at every node and current flowing through the branches, right? Now it is clear to all of you.
Yes, sir.
Okay, okay, thank you. Then we will move towards super mesh method. Okay, so this is a special case of mesh method. In mesh method, you have to look at the number of meshes, okay, in the circuit. Means what are the individual loops are there in the meshes, and then we have to take current direction in the meshes. Based on the meshes, means we have to number the meshes, mesh 1, mesh 2, mesh 3, mesh 4, like that. And then we have to assume currents. In mesh 1, I1, mesh 2, I2, mesh 3, I3. And as I told previously that the current direction, for simplicity, we take current direction equal. Okay. If you are taking clockwise, we will take clockwise direction for all. Okay. If we are taking anti-clockwise, then also we will take anti-clockwise for all for simplicity. Okay. There is no restriction to take current direction in anywhere, any circuit. Okay. You can take as per your own choice. But for simplicity, if you will take clockwise direction, it will be easy. Okay. So we will take this problem to look at the super mesh method. In super mesh method, just like in previous example, we have seen that in super node, if there is a voltage source in between two nodes, it will be considered as a super node. Okay. Like that, in super mesh, if there is a current source in between two meshes, okay, there we are talking about nodes. In between two nodes, if there is a voltage source. Here we will talk about if there is a current source in between two meshes or two loops. Then this problem can be solved very easily by using super mesh method. Very simple. Understand? So if there is a current source in between two meshes or loops super mesh method can be applied for simplicity. Okay. So means if there is a current source in between two meshes or loops. So in this example, can you find a current source in between two meshes?
Yes, sir.
Okay. So you can see that there are three loops, individual loops that are also called as meshes. There is a difference between loop and mesh that inside the mesh, there should not be any other loop. Okay. So you can see that there are three individual loops. This one, loop 1, loop 2, loop 3. So this is loop 1, this is loop 2, this is loop 3. And you have denoted the current direction in all clockwise, I1, I2, I3 in all three loops. And you can see that in between loop 1 and 3, there is a current source in the circuit, right? So this is a case of super mesh method. Okay, this is a case of super mesh. And as per super mesh, we will take an outer loop which includes both meshes. Consisting of the current source. Okay. And apply KVL in the outer loop. मतलब क्या है कि if there is a current source in between two meshes, so what we can take? We will assume this one as a outer loop. So you can see that the dotted line is represented here. This is a outer loop consisting of both loops. Means we will combine both loops and we will consider this outer loop as a super mesh. So this outer loop is a super mesh. So in this outer loop, we will apply KVL and we will write KVL equation, just like previous cases. And also together with KVL, we have to apply another KCL also, so that we can get another equation to solve the variables. Because we have three variables, I1, I2, I3. If we apply KVL in the loops, so we will consider, if we will apply KVL in this loop very easily, that is in loop 2, and another KVL we can get in the super mesh. So there are two equations we are getting straight away, but we have to look for third equation also, so that we can calculate the value of I1, I2, I3. So to get third equation, we have to apply KCL also. This is the thumb rule. Okay. Clear? So till now, is there any doubt? Till now, is there any doubt?
No, sir.
Okay. Thank you. So now we will write KVL equation. So we will apply KVL. KVL in KVL in loop 2. लूप 2 में KVL अप्लाई करेंगे. तो कैसे करेंगे?
No, sir.
What?
No, sir.
Can we apply KVL in loop 2? No. We can apply because we have assumed the current direction. Current in the loop, that is I2. So what is current flowing in this branch? I2. What is current flowing in this branch?
I2 minus I3 or I3 minus I2, जो भी बड़ा.
Yeah. So the current flowing through this branch, if we are taking in this direction, this is the resultant current. So it will be I2 minus I3, right? I3 is coming in this direction. I2 is coming in this direction. So here the resultant current will be I2 minus I3. Clear? What will be the current in this branch? If we are taking in the upward direction. So which one is dominating?
I2 minus I1.
Yeah. Correct. I2 minus I1. Okay. So if we want to apply KVL in loop 2, we have to denote the currents like that, and accordingly we have to write the voltage drop also. You know that this is an element, and in element current will flow from higher potential to lower potential. That's why plus will be here, minus will be here. If we have assumed current direction in this way, so the voltage drop across this 3 ohm resistor will be plus here, minus here. Am I right? Plus here, minus here, because current is flowing from here to here. So current will flow from higher potential to lower potential. That's why current direction is here. What will be the polarity of voltage drop in 1 ohm? Where it will be plus, where it will be minus?
Downside plus upside.
Yeah, downside plus, upside minus. Clear? So now we can apply easily, apply KVL in this loop 2. We can start at any point. Suppose we are starting at this point and we are moving in the clockwise direction and we are reaching at this point. So we can complete the loop. So if we start from here, we are moving in this direction, clockwise direction. So first element will come, that is 2 ohm, and the voltage drop across 2 ohm is, firstly we are approaching to the plus, then we are approaching to minus. So as per the passive current voltage convention, we will take this plus as a minus. So voltage drop will be minus of 2 into I2. Am I correct? The voltage drop across 2 ohm resistor will be 2 I2. right? Because I2 is flowing in this branch. 2I2, right?
Yes, sir.
What about the voltage drop across 3 ohm? 3 into I2 minus I3, 3 into I2 minus I3, right?
Yes, sir. Yes, sir.
And what will be the polarity?
Negative.
Negative. Just,
Negative on the left side.
just like to the previous, okay, previously also we have got plus first, then we are getting minus. In this case also we are approaching to the plus first, then we are going to the minus. So 3 into I2 minus I3. Now the voltage drop across 1 ohm resistor will be 1 into I2 minus I1, right? It will be again minus, because first we are getting to the plus, then we are going to minus. So 1 into I2 minus I1. So one equation we got from here, minus 2I2, that will be 0, obviously. So all minus are there, so we can take plus here by taking minus common and sending to the right side of equal sign. So it will be plus 3I2 minus 3I3 plus I2 minus I1 is equal to 0. So minus I1 plus 2I2 and plus 3I2, that is 5I2. 5I2 plus I2, 6I2 plus 6I2 minus 3I3 is equal to 0. This is equation number 1. So by applying KVL in loop 2, we got first equation. Now we will apply KVL at super node. KVL in super node, super mesh, sorry. So KVL in super mesh. If we apply KVL in super mesh, we have to take this outer loop. Okay. So you can see that here already we have assigned the polarity of voltage drop. Here also it is there, but here it is not there. In one where current flowing is I3, you can see that in this 1 ohm current flowing is I3 downward. Okay. So what should be the polarity? Where it will be plus, where it will be minus?
ऊपर प्लस नीचे माइनस.
Right. Upper plus, niche minus, because current will flow from higher potential to lower potential. तो अब इसमें हम KVL अप्लाई कर सकते हैं. This is our voltage source. This is one resistor. This is another resistor. This is third resistor. So while moving in the loop or super mesh, we have to calculate the voltage drop, all voltage drop, a algebraic sum of all voltage drops. So we will start at this point. If we will start at this point, first our 7 volt will come, then 1 ohm resistor, then 3 ohm resistor, then 1 ohm resistor, and again we will reach at this point in this loop, in this super mesh. Okay. So we are starting from here. Firstly, minus will come, minus to plus, it will be plus 7, then minus to plus 1 into I2 minus I1, then minus to plus 3 into I2 minus I3, then plus to minus 1 into I3, that will be 0, right? So we will write the KVL equation. We will start at this 7 volt. So plus 7, then we will take this one voltage drop across 1 ohm minus first, then plus. So it will be plus 1 into I2 minus I1. Then again here minus 2 plus 3 into I2 minus I3. Then again, then we are getting going from plus to minus. So minus 1 into I3, that will be 0, right? Is there any doubt in this KVL equation, writing KVL equation?
सर ये जो I2 माइनस I3 अज्यूम किया है हमने, ये I3 माइनस I2 भी अज्यूम कर सकते थे.
राइट, बिल्कुल कर सकते हैं,
ओके सर.
बट करंट डायरेक्शन हमको यहाँ लेना पड़ेगा, अपोजिट करना पड़ेगा करंट डायरेक्शन.
यस सर, मतलब स्टार्टिंग से ही I3 माइनस I2 कंसीडर करें.
यस यस, स्टार्टिंग से करेंगे तो हम दूसरे के लिए करेंगे तो फिर कंफ्यूजन होगा ना. एक इक्वेशन के लिए आप एक डायरेक्शन में ले रहे हो, दूसरे इक्वेशन के लिए दूसरे डायरेक्शन में, तो वो तो गलत हो जाएगा, क्वेश्चन ही गलत हो जाएगा.
यस सर.
इनिशियली आपको एज्यूम करना है, जिस भी डायरेक्शन में करंट एज्यूम करना है वो आप फाइनल मान लो. अगर एजम्पशन आपका सही होगा तो पॉजिटिव आंसर आएगा, एजम्पशन गलत होगा तो नेगेटिव आंसर आएगा. सिंपल.
ओके सर.
Okay. So we will simplify this equation. Equation number, we can write I2 minus I1 plus 3I2 minus 3I3 minus I3 plus 7 is equal to 0. Okay, so we can write minus I1, 3I2, I2, 4I2 plus 4I2, then minus 3I3 and minus I3, that is minus 4I3 is equal to minus 7. That is equation number 2. So we got two equations by applying KVL in two meshes. Okay, one is individual mesh, another one is super mesh. So how we can get third equation? Can anyone tell how we can get third equation? We have applied
by
KVL.
applying
Now we
by
have to
applying KVL in any other left loop.
no, we will not apply KVL in other loops. We have applied KVL in two loops. Now we will apply KCL to get third equation. How we can apply KCL and what will be the third equation, and where we will apply KCL?
Maybe at the center point. Center junction.
Center junction where 7 ampere is there, right? If you look at your 7 ampere current source, and what is the current flowing in this branch in terms of your variables, assumed variables, what will be the current flowing through this branch? Ultimately, the 7 ampere will flow in this branch. There is no doubt. It will not change. Current will be same, 7 ampere only. But in terms of your variables, if you write equation, you can write one equation based on this 7 ampere, and that will be your KCL. So KCL with 7 ampere current source. What will be KCL? What will be the value of 7 ampere in terms of I1 and I3? I am telling clearly. What will be the value of 7 ampere in terms of I1 and I3?
I1 plus
I1 minus I3
I1 minus I3 plus 7.
I1 minus I3, right?
equation. Yes.
I1 is flowing in downward direction. I3 is flowing here in upward direction. In this loop, in this branch, if you see that this is loop 3, so I3 will flow from bottom to upper. So this will be I3, this will be I1. So ultimately the current source value is 7 ampere and direction is downward. So which will be dominating? I1 will be dominating, right? So I1 minus I3 will be the resultant current in this branch. So that KCL equation will be I1 minus I3. I1 minus I3 is equal to 7. That will be your third equation. Is it clear to all of you?
Yes, sir.
I1 माइनस I3 इज इक्वल टू 7, क्योंकि रिजल्टेंट करंट जो है इसमें I1 आ रहा है, इस लूप के चलते इसमें I1 जाएगा, इस थर्ड लूप के चलते इसमें I3 जाएगा, दोनों का डायरेक्शन अपोजिट है। एंड डोमिनेटिंग करंट जो 7 एम्पियर करंट अल्टीमेटली इसमें फ्लो करेगा, वो उसका डायरेक्शन जो है I1 के डायरेक्शन से मैच हो रहा है। सो इट मीन्स I1 ज़्यादा होगा, I3 कम होगा, तभी दोनों का डिफरेंस 7 एम्पियर रहेगा, राइट? So I1 minus
Yes,
3
sir.
is to 7. Clear? कोई डाउट है इसमें?
No, sir.
So if you will solve equation 1, 2 and 3, you can get easily the values of I1, I2 and I3. Okay? Just like in the previous, in super node, you have seen that this is V1. In between V1 and V2, there was a voltage source 2 volt. This was V2. Okay? And this you have considered as a super node. So by applying KVL at this super node, you have written a KVL equation V1 minus V2 is equal to -2. लिखा था ना वहां पे सुपर नोड में। सिमिलरली यहाँ पे सुपर मेश में हमारे पास ये इक्वेशन है, इसमें दो लूप के बीच में एक करंट सोर्स है, करंट सोर्स का वैल्यू 7 एम्पियर है, एंड इस लूप में करंट I1 है, दिस इज लूप 1, इस लूप में करंट I3 है, दिस इज लूप 3, ओके। और ये इन बिटवीन दिस टू लूप्स, दिस इज ए कॉमन, this current source was common. So if you will write KCL equation, I1 minus I3 is equal to 7. Okay. So now we can easily solve some circuits based on super mesh and super node. Okay. And that will simplify, simplify the circuit solving technique. Okay, you can easily get your answers by with very minimum number of equations. Okay. Is it clear to all of you? If there is any doubt, you can ask.
No, sir.
So in the next class, हाँ,
सर मेरा एक डाउट था, लाइक इन लूप 3 सर हम लोग केवीएल यूज नहीं कर सकते हैं?
लूप 3 में KVL यूज कर सकते हैं, बट करंट सोर्स के क्रॉस कितना वोल्टेज ड्रॉप है ये हमको नहीं पता है, तो वो अनदर वेरिएबल हो जाएगा जो हमको आइडेंटिफाई करना पड़ेगा। ठीक है,
ओके सर।
ये सबसे बड़ा चैलेंज है इस टाइप के प्रॉब्लम में। जैसे यहाँ पे ये वोल्टेज सोर्स है, अगर कोई और एलिमेंट होता, इस सुपर नोड क्यों बोल रहे हैं इसको, क्योंकि इसको सॉल्व करने में, सिंपल मेथड से सॉल्व करने में डिफिकल्टी है, क्योंकि इसमें करंट कितना जा रहा है वो हमको पता नहीं है। I4 अननोन है यहाँ पे। I4 क्योंकि हम फाइंड आउट नहीं कर सकते हैं, I4 यहाँ पे हम कर रहे थे ना, I4 इज इक्वल टू V1 माइनस V2 बाई समथिंग होगा, बट वो रजिस्टर और इम्पीडेंस जो भी है वो कितना है 2 वोल्ट के क्रॉस वो हमको नहीं पता है, राइट।
ओके
इसलिए
सर।
I4 हम यहाँ पे I4 एक अनदर वेरिएबल हो जाएगा जो हमारे लिए चैलेंजिंग होगा, जो एक और इक्वेशन डिमांड करेगा सॉल्व करने के लिए। ठीक
ओके
है,
सर।
हाँ, ओके। इज देयर एनी अदर डाउट? Okay, so from the next class, I will start network theorems, where in the network theorems, there are 4 network theorems that we have to study. That is, first one is superposition theorem. Second one is Thevenin's theorem. Third one is Norton's theorem. And fourth one is maximum power transfer theorem. Okay. There are various applications of these network theorems. If you will find in your upcoming courses also that you are applying superposition theorem, Thevenin's theorem, you have to apply maximum power transfer theorem for particular problem, okay, while solving your device, circuit based on devices, whether it is IGBT, MOSFET, okay, if you are tackling or if you are solving the circuit based on devices, in that also you may have to apply these theorems, and that will simplify the circuit and you can get your answer easily. Okay, maximum power transfer theorem is the special theorem where you will identify for what condition the maximum power will be transferred from the source to load side. Okay, means if source is delivering power to the any load, so how much power, maximum power that source can transfer to the load, and for that what will be the condition. Superposition theorem is another theorem where suppose there are many sources in the circuit, there are various sources, means if you think there are 5 or 6 sources in the circuit and that circuit will be complex, right? So in that, in superposition theorem, you have to consider each source at a time and you have to eliminate other sources. And how we will eliminate, I will tell you in the while discussing this theorem. Similarly, in Thevenin's theorem, what we can do, if there is an open circuit anywhere, or if we have to identify the current through any element, so firstly we have to remove that element and we have to calculate the voltage across that open circuited terminal, okay, and we will calculate the equivalent impedance across the terminal. Means any network, any linear time invariant network can be transferred into a voltage source, equivalent voltage source in series with the equivalent resistance or impedance. That is the principle of Thevenin's theorem. Okay, and Norton's theorem is just a dual of Thevenin's theorem. Means just it is a voltage to current source conversion. In Thevenin's theorem, the whole network is being converted into a single voltage source and single impedance in series. Okay, so you know that a voltage source in series with the impedance can be converted into current source, where the current source value will be voltage divided by impedance, and you have to connect that impedance in parallel with the current source. Okay, so this is just voltage source to current source conversion. So Thevenin's and Norton's theorem both are dual to each other, dual, and you have to apply source conversion. So this is nothing but source conversion. Both are dual in nature. The equivalent resistance will be same for both theorems, and the procedure to calculate the equivalent resistance or impedance will also be same in both theorems. So we will see one by one these theorems in the next class. And the previous recorded lectures I have uploaded in the Google Classroom, so you can find it. All recorded lectures of the previous classes I have uploaded today. For remaining upcoming lectures, I will upload in between in future. Okay, so if you want to see, or if anyone have joined late, so they can take the opportunity and they can see the video lectures to understand the lecture. Okay, understand the concept. And I have also uploaded this material for this for your help up to nodal and mesh analysis. For upcoming network theorems, I will also upload some materials regarding this, so that you can be ready before that your lecture, so that you can understand lecture very well. So I will try to send today itself the network theorems, means material based on network theorems, right?
Okay, sir.
Okay, thank you. Then I will take your attendance. Yeah, one more thing. This Shashi Shekhar Mishra. Are you there? Shashi Shekhar Mishra. Swastik Mishra. Yes,
Present, sir.
Yasvardhan.
Swastik Mishra.
Yasvardhan Chauhan also. Swastik Mishra, your branch is electric vehicle, right?
Yes, yes,
Electrical engineering major in electric vehicle.
yes,
This,
sir.
this class is for electronics student only. So there is another faculty teaching that subject for EV students. So you have to join the another lecture. Okay. I am teaching only for electronic students.
Okay, sir.
Yeah. So I told to that another faculty also who is teaching for EV students, that this Shashi Shekhar Mishra, Swastik Mishra, and Yasvardhan Chauhan, all three are EV students. So they have to join another class. Okay. You can
सर दूसरे क्लास की लिंक ये सब आएगी?
लिंक मिल जाएगा आपको, आप सर को एक बार कांटेक्ट करो. ओके, या मैं दे देता हूँ उनको. ठीक है, आप लोगों का कांटेक्ट मैं उनको दे देता हूँ, आप लोगों का ईमेल आईडी.
ओके सर, थैंक यू.
तो टाइम टेबल में तो आपको ईवी का पता है ना कि क्या क्लास टाइम टेबल है?
यस सर, टाइम टेबल पता है.
ज्वाइन करना है. उस पर्टिकुलर टाइम टेबल पे। मैं सर को दे दूंगा ईमेल आईडी, आप लोग अपना ज्वाइन कर लेना। ओके, आशीष चंद्रा, अव्या चंद्रा,
प्रेजेंट सर।
आदित्य आरएस,
प्रेजेंट सर।
आकाश,
प्रेजेंट सर।
अखिलेश साहू,
प्रेजेंट सर।
अक्षित,
प्रेजेंट सर।
आनंद,
प्रेजेंट सर।
अंकित,
प्रेजेंट सर।
अपूर्व,
प्रेजेंट सर।
अर्णव, अविनाश,
प्रेजेंट सर। सर अर्णव कुमार प्रेजेंट।
यस यस, आयुष,
प्रेजेंट सर।
गौरव,
प्रेजेंट सर।
ईशांत,
यस सर।
कृष्णा, मैत्री उपल,
प्रेजेंट सर।
मुद्रा,
प्रेजेंट सर।
परांजय,
प्रेजेंट सर।
प्राची गौतम,
प्रेजेंट सर।
प्रज्वल,
प्रेजेंट सर।
प्रियांश,
यस सर।
प्रियांशु,
प्रेजेंट सर।
पुलकित,
प्रेजेंट सर।
राहुल, राजीव कुमार पांडे, ऋषभ,
प्रेजेंट सर।
ऋषभ, राइट,
यस सर, यस सर।
रोहन कुंतल, देन एस ऋतिक साई,
प्रेजेंट सर।
साकेत सुमन,
प्रेजेंट सर।
सम्यक, कश्यप, संग्राम,
प्रेजेंट सर।
शशांक,
प्रेजेंट सर।
शुभम रंजन, शुभम सिंह,
प्रेजेंट सर।
सृजन स्वरांकर,
प्रेजेंट सर।
सुधांशु,
प्रेजेंट सर।
सुजीत कुमार, सुमित सिकरवार,
प्रेजेंट सर।
सुप्रिया,
प्रेजेंट सर।
सूर्यांश,
प्रेजेंट सर।
उज्जवल,
प्रेजेंट सर।
उत्कर्ष,
प्रेजेंट सर।
वैष्णवी,
प्रेजेंट सर।
वेदांशी,
प्रेजेंट सर।
विशाल,
प्रेजेंट सर।
यश बावास्कर, अर्णव हो गया, विनीता,
प्रेजेंट सर।
संभवी श्रीवास्तव। ओके, सो स्वस्तिक, आई एम noting down and I will tell to the another faculty for all 3 EVA students.
Excuse me, sir.
Yeah, Akshit.
Yes, sir. So yesterday, actually, sir, I was out of my home for 4 or 5 days. Sir, I came home late. I had already
Recording
done my
stopped.
assignment, but by the time I submitted, it got a bit late.
No issues. This was first
And
time, so there is
yes,
no
sir.
issue. Okay.
Sir, I submitted 8 minutes late, and it is showing turned in all late.
Yes, it will definitely so because due date is there, na, due time.
Yes, sir. So I actually personally mailed you also 2 minutes back.
No issues,
Like
no issues.
before the deadline.
From next time, try to submit quite ahead. Okay.
Yes, sir. So next time it won't happen. I'm
Okay.
sorry, sir.
Okay, no issues, no issues.
Okay.
Okay.
सर
You and yeah, Paranjay.
सर अभी जो आपने ट्यूटोरियल दिया है तो वो उनको एज असाइनमेंट सबमिट करना है 30 तारीख से तो।
Yes. आप इसमें अपलोड करके सबमिट करोगे जो जैसे असाइनमेंट किए हैं ना, जैसे सॉल्व करके उसको
सर।
पीडीएफ बना के सिंगल पीडीएफ अपलोड किया, सिमिलरली
ओके
वैसे
ओके
तो ट्यूटोरियल भी करना है। मतलब
थैंक
पता तो चले कि आप सॉल्व कर रहे हो, ठीक है।
यू। यस सर।
फिर उसके बाद हार्ड कॉपी यहाँ पे भी चेक करेंगे जब ऑफलाइन आप लोग आओगे तो, ठीक है। वो कॉपी लेते हैं ना
यस
जिसमें कर रहे हो।
यस सर।
ओके, ठीक है। ठीक है, फिर नेक्स्ट क्लास में मिलते हैं। थैंक यू।